quick refresh, tangent, when we graphed it, we went from negative pi over 2 to positive pi over 2. And with cotangent, we went from 0 to pi. The reason being we wanted a full, complete cycle with an asymptote in the middle. Tangent was increasing, it looked like this. Cotangent was decreasing, it looked like this. One way to remember that, like tangent, this is quadrant 4 over here, and tangent is negative in quadrant 4. And then this is between 0 and pi over 2, that's quadrant 1, and it's positive in quadrant 1. From here, 0 to pi, that's quadrant 1, cotangent's positive there. From pi over 2 to pi, that's quadrant 2, and it's negative. So the positive and negative are why we see the increasing and decreasing. So when we graph these, we're still going to do all the same things. We're going to do the amplitude. It's not like a true amplitude here because there is no highest and lowest point. They keep going forever, but it gives us an accurate point on our graph. Then we'll find our period and our count by so that we have points to put on the x-axis. We always are picking our intervals so that we will have asymptotes at the two ends and 0 in the middle. And then we can sketch our graph from there.
Amplitude in quotation marks?
So amplitude we were using as like the highest and lowest points on sine and cosine because
But they
tangent
go
keeps
forever.
going up, it doesn't really have an amplitude. But that point is going to be a point on the graph.
I wanted to tell you this morning. We weren't here, and I don't remember what the actual context of it was now. But I woke up this morning. I did not want to get out of bed, and I got out of bed.
Spring cleaning.
Okay, let's draw a graph. I do have a suggestion for tangent and cotangent. It can be useful to do the interval every single time. With sine and cosine, we only had to do it when you were adding or subtracting, which shifts your graph left or right. However, because I'm not starting at 0 and ending at 2 pi every time, changing your period can change those starting and stopping points. So my suggestion is just to always do the interval. It'll make life a little bit easier and require a little less thought. So our amplitude, we look the same places as sine and cosine. So that's a number out in front, so that would just be 1. Period. Now here is a little bit different. Sine and cosine, we do 2 pi divided by the number in front of x because it normally takes them a period of 2 pi to repeat. But how long did it take before tangent and cotangent started repeating? 1 pi. So we do 1 pi, the normal period, divided by the coefficient of x, which is 2/3.
So it's just 2 or 1 over.
3 pi over 2.
Yeah.
Okay, count by is going to be the same. We want to split it up into 4 quadrants essentially, even though we're not really doing 4 quadrants, will give us the number of nice points that we needed. So we'll take our period divided by 4.
3 pi over 8.
And let's go ahead and do an interval. Where do we normally graph tangent?
On the 0.
Well, we start at negative pi over 2 and end at positive pi over 2. So tangent and cotangent are going to be the weird ones. They have different rules. Okay, so if I wanted to solve for x, I could multiply by the reciprocal, 3 over 2. So I get a negative 3 pi. It's less than or equal to x. It's less than or equal to 3 pi. Not just 3 pi, 3 pi over 4. Sorry. Negative 3 pi over 4 to positive 3 pi over 4. Okay, so for my graph, I have 0 in the middle. Please attempt to space these evenly. If you put all your points and they're not spaced out evenly, fix it. Starting at negative 3 pi over 4. If you add your count by, this is like negative 6 pi over 8 plus 3 pi over 8 would be negative 3 pi over 8. Plus 3 pi over 8 is 0. Plus 3 pi over 8 is 3 pi over 8. Plus 3 pi over 8 would be 6 pi over 8, which is 3 pi over 4. And isn't that where our interval was supposed to end? All right. Amplitude is 1. We know it's not really true amplitude, but I'm going to mark 1 and -1 on my y. So we pick this interval so that we know both ends are vertical asymptotes. And the middle is 0. Does tangent go up or down?
Down. It goes down from the left and it goes up.
Yeah.
Because you read from left to right.
So we start over here. This will be at -3/8 will be when it's at its negative amplitude. +3/8 would be at its positive amplitude. Now, this is not a line, it's a curve. Asymptotes are lines we're getting close to, but not actually touching. So make sure you're drawing your graph approaching those.
Wait, I don't know how to draw this correctly. Can I have helpful tips for this stuff?
It's sometimes easier with tangent, cotangent if you space out your left x-axis less. Make your points on the x-axis closer together, and it will be easier to curve them.
I think I'm just curving them too much, like too many times.
There's one curve.
I think I'm doing too many curves.
Yeah, this is just like a nice no curve in the middle there.
Thank you, helpful tips.
Yes.
Tips for this stuff.
Kind of like an x cubed graph.
Oh, up is easy. Okay.
Questions there? Let's look at another one. So, what is our amplitude? What does the negative do?
Hit it across the x-axis?
Yes.
Wouldn't that make it cotangent?
It'll make it the shape of cotangent.
What the heck? Man?
All right, our period. Normal period for tangent and cotangent is
Pi, I mean.
pi, divide by the number in front of x, so pi over 2. Count by, we take our period and divide by 4
Yeah. What is that?
over 8.
20 or whatever.
Okay, strongly recommend doing an interval every time for tangent and cotangent. So we set it up between negative pi over 2 less than or equal to 2x less than or equal to positive pi over 2. Alright, then we can divide everything by 2. So we get negative pi over 4 less than or equal to x less than or equal to positive pi over 4.
Will it always be this like the same?
Not if you move it left or right.
Oh, because you'll subtract one side and
Mhm.
add, or because one side. Yeah, I gotcha.
So first point at negative pi over 4. Add pi over 8, so negative 2 pi over 8 plus 1 pi over 8 is negative pi over 8. Plus pi over 8 is 0. Pi over 8, and 2 pi over 8 is pi over 4. We do this so that both ends are vertical asymptotes. Okay, normally tangent starts down and goes up, but we flipped it so it will start up. So at negative pi over 8 we'd be at positive 1/2. 0, 0 at pi over 8 will be at negative 1/2. And the 1/2 because that's our amplitude.
I don't know why cotangent is so much easier to draw than tangent. remember my joke now. It was, this is not my domain, and I stood there for a second, I went, it's not my range either.
Let's try one more basic one and then we'll throw in left, right, up and down movements. Amplitude,
3.
period,
Isn't it 1/4?
pi divided by 1/2.
Oh, it's pi over 2. 2 pi? Interesting. I'll just say numbers until I get them right.
So count by, period divided by 4, pi over 2. Interval. What interval do we use for cotangent?
Oh, the opposite of tangent.
1 to
It's-
2.
We go
We could start at
Zero,
0 for
and then pi.
cotangent.
0 pi.
Oh, that's right.
Why?
Because it's, yeah, that's right.
So then if we multiply by 2, we get 0 less than or equal to x less than or equal to 2 pi.
Oh, because I understand now.
If you don't use this interval, that's okay, but then you're going to have to figure out where your asymptotes fall. So first point is at 0, counting by pi over 2. So next is pi over 2, 2 pi over 2 is pi, 3 pi over 2, and 4 pi over 2 is 2 pi. Amplitude is 3, so 3 above, 3 below. We pick this so that both our starting and stopping point are vertical asymptotes, and the middle point is at 0. So when I'm at pi, we have 0. Now, we have to think about the shape. What does cotangent look like?
It's decreasing.
Decreasing. It starts positive because we're in quadrant 1. So here it would be at the positive 3, and then it goes negative. So 3 pi over 2 would be at negative 3.
I'm just throwing right through my equation.
Happens.
Not necessary for this problem anymore.
Alright. Let's do 2 more. We haven't done 2 periods one, so let's try that.
That means that it's tan x minus 3, right?
Yes. So if you don't like how it's written,
Sorry, tangent.
put that in. So what's our amplitude?
1,
Period.
what is it? Pi, right?
Yes. Tangent and cotangent have a normal period pi. What is our count by? Pi over 4. Interval. For tangent, we go between what?
0 and, oh no, it's not.
Negative pi over 2 to pi.
I got lost.
And our angle is just x, so that's not going to change. What else is happening on this graph?
We're moving right. Or we're moving down.
You don't ever want us to actually write that, do you? Or like,
I mean, it's
I
good
write
to
it.
note. I usually write it down. Then if you write it down, but you fail to do it on your graph, then I will take off less than if you don't do either. If that makes sense.
so write it
So
down.
just.
It's
don't
just
forget
like
to
writing
put it
your
on the
reference
graph.
angle.
I
Only
It's
don't if you're
insurance.
confident.
Yeah.
Yeah.
So
As long
we
as you don't forget it on the graph, you chill.
Yep.
Yeah.
start at negative pi over 2. So it's like negative 2 over 4 plus 1 over 4 is negative pi over 4. Plus 1 over 4 is 0. Positive pi over 4. Positive pi over 2. Okay, our graph has moved down 3. So what we're going to do is go to negative 3. And how do we do it for sine and cosine? You guys remember?
Make a little dotted line.
We did a dashed line there to show that's going to be the center. Since my amplitude is 1, we'll be going 1 above and below that graph, or that mark. Starting and stopping point are asymptotes. The middle point is 0, but 0 is on
The
the
negative
-3 line. Okay, then is tangent increasing or decreasing?
Increasing.
Increasing. So at negative pi over 4 is when we are at -4, and pi over 4 is when we're at -2. Now, I asked for 2 periods, so what do we have to do?
Do it again.
Do it again. We can add it in either direction, or if you really wanted to be fun, you could do half in each direction. But we just really need 4 more points.
Why would you want to do that?
Added challenge. Okay, so if I keep adding my pi over 4, that would be 3 pi over 4, pi, 5 pi over 4, 6 pi over 4 is 3 pi over 2. The beginning of this period is an asymptote, the end of this period is an asymptote. And the middle of it, we should be at our 0 mark.
I forgot about pi.
So then we just repeat.
Is that one last one 3 pi over 2, right?
Yes.
Third graph. So good at graphing. I know how to bend it now.
Any questions there?
Are we going
Not
left,
yet.
left and right now?
Yes. Let's do one with
And,
everything.
I like that we didn't do a left and right by itself.
Yeah, we're big kids.
I'm a big kid now.
What's our amplitude?
1.
Yep, it's the number multiplied out in front, so just a 1. Period. Normal period for tangent and cotangent is pi divided by the number in front of x, which is just 1. So our period is still pi. So our count by would be
Pi over 4.
interval. For cotangent, we go
0 to pi.
0 less than or equal to the angle. Less than or equal to pi. So if I subtract pi over 2, we get negative pi over 2 less than or equal to x less than or equal to positive pi over 2. What else is happening?
We're going up 3.
Start at negative pi over 2. Add pi over 4. So it's negative pi over 4. 0. Positive pi over 4. Positive pi over 2.
I thought it was 2 pi.
Sine and cosine are, but tangent and cotangent repeat sooner, so we have weird intervals that we pick for them.
2 pi was just for the example.
I was just showing you that it started repeating. Okay, we pick this because then both ends are vertical asymptotes.
Cotangent equal to pi.
And then the middle is 0, which is on our positive 3. Now cotangent, does it increase or decrease? Decreases. So at negative pi over 4, we will be 1 above this line. Positive pi over 4 will be 1 below. For the second period, we just add 4 more points. So keep adding your count by. 2 pi over 4, pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2.
I made a little firework by accident. It's so cute.
And now we're asking for it at the end. In the middle, we're on our 0 line, which is at positive 3. And the graph is decreasing. Questions on these?
Kind of unrelated. When would you actually need this?
Well, the trig functions can be used to model a lot of different things, like wave patterns, sound waves, lots of things. Even in music, some different musical patterns. So then the graphs show a visual of it. Okay.
I do one period.